this video, we will be given graphs, and our goal is going to be to find the equation or find a equation to represent that sinusoidal function. So to begin, we're going to refresh on how each part of the sinusoidal function relates to a property. So we know the a value helps with our amplitude. The negative tells us the reflection. The x minus d part is your phase shift, and it tells you where the cycle would start. That cycle that used to start at the origin, where is it going to shift to? And the plus c relates to the central axis. So we're going to look at our first example here. I have a function. I want to determine my properties. So first thing, I always start with the max and min. The maximum is at 2. The minimum is at -4. With that, I can get my amplitude and my central axis. So first of all, halfway between 2 and -4, just visually, I can see it's at -1. If I'm not doing it visually, I'm just adding my numbers and dividing by 2 to get the middle. So if I were to go the long way, 2 plus -4 divided by 2 is that -1. This is going to be the number at the end of my sinusoidal function. So actually, I'm going to start. My function will end with -1. Now my amplitude, I can see it from my graph. 3 units above the midline, 3 units below. But again, if I can't see, max minus min to find the distance between the max and min, and then cut that in half, which gives us the 3. That tells us our a value will be 3. Maybe it's positive, maybe it's negative. We can actually choose that part. Now, I'm going to put sine in, and then I'm going to have a bracket here for the phase shift. Depending on what I choose for my starting point, that will dictate the phase shift and if there's a reflection or not. So I'm actually going to write 2 different equations to represent this sinusoidal function. I'm going to choose for my first equation to use this as a starting point. If I'm using this point, the original sine function started at the origin. It must have moved to the right 30 degrees and then down 1. I already have the down 1 covered. So I just need to add in right 30 degrees, which is x minus 30. Now, based on my starting point, this function heads to the maximum, so there's no reflection. So here is equation number 1. I'm going to change it up. Maybe I want this to be my starting point. So for my second equation, I'm still using the same amplitude. I still have the same central axis for the down 1, but now, from the point I chose, I'm heading down to the minimum, which now adds a reflection. And this point is also to the right 210 degrees. So x minus 210. I can come up with even more. If I use this as a starting point or this as a starting point, there are 2 more equations I can come up for this one function. And if I were to zoom out, even more equations. And that's it for finding the equation. Actually, let me fill in based on equation 1. For the starting point, I chose 30, -1, and there was no reflection. Okay, let's try one more. So I'm going to highlight. My maximum is 4.5. My minimum is 1.5. Now maybe it's hard for you to see the middle with this, although I think it's 3, but I can do the calculation, add my numbers, and divide by 2. That's going to give me 6 divided by 2, which is 3. So let's start that equation. It's going to be plus 3 at the end. I can see my amplitude is this. Looking carefully to my scale, this would be 1.5. But if you don't want to or you're unsure of it, subtract max minus min divided by 2. That's 3 divided by 2, which is 1.5. So my a value is 1.5, and I just have to think of my starting point and if there's a reflection. I'm going to choose this point this time. It's at negative 120 degrees, comma, 3. So that means I must have shifted to the left 120, which means x plus 120, because the original point used to be here at the origin. So we must have gone left 120, up 3. Here's the left 120, here's the up 3. And now, from the starting point I chose, we're heading up to the maximum, so there's no reflection. So this here is a good equation. But let me come up with one more. I'm going to use this point. This time, we're heading down to the minimum, which means there's a reflection. The amplitude has not changed. My shift, well, now we're going to the right 60 and then up 3. So right 60 means x minus 60, and then the plus 3. And that's it for finding equations. So identify your max and min. This will help you with your amplitude and your central axis. That's your A value, and that's your C value in the equation. Choose a starting point that's on the midline. You get to choose it, which means you're choosing your phase shift, and you're choosing if there's a reflection or not. And there we go.